Ready? You invest $18,000 at 3.21% interest compounded continuously. So remember that continuously ends with an E sound, right? So that means you should use the formula that has the E in it. So if interest is not compounded continuously, then you'll use the first formula. But if it's compounded continuously, then you use the formula with an E, because E rhymes with E. So the amount of interest that you'd have is P of T equals. So what is the P? Now the way this is the standardized final, the way it looks, and it looks a little bit different than what we learned in class. In class, we learned the formula PERT, P-E-R-T, right? So P0 is called P naught. That just means the principal amount. That's the money you had at the beginning. So the P naught is equal to $18,000. So fill in $18,000 for that. And then the E is just E. And then the K is the same as what we called R. So K and R both represent the interest rate, except you have to convert the interest rate to a decimal. So if you take 3.21 and convert that to a decimal, move that over once, move it over again. So you'd have 0.0321. So 0.0321, like that. So the interest rate is equal to 0.0321, and time is the time, which is 5 years. So put in 5 for the time. So I'm using this formula, and I'm putting these numbers into it. And actually, I forgot to plug in T is also 5. So technically, this T also should be a 5 as well. So the principal amount after 5 years would have been larger than it used to be, and it would be this. So I'm just putting in the 5 for the other T as well. So basically, you can think of interest as a formula, like a function like f of x, for example. If you plug 5 into f of x, it's called f of 5. If you plug 5 into the formula for the money, it's called P of 5. So the amount of money you'll have in 5 years is called P of 5. And it is 18,000 E to the 0.0321 times 5. So there we go. Now it says if you have no calculator, by the way, I bought like $80 worth of calculators for you. So there's a box in my office with all kinds of calculators now. So 5 times 0.0321 is how much? If you don't have a calculator, you can just leave the answer like this. So basically, since I don't have one, I'm just going to leave it like this. Although I do feel like it's a challenge, though. Do you think we can figure this out in my head? Let's see. 300 times 5 is 1,500, right? 20 times 5 is 100. So that'd be 1,600. 1 times 5 is 5. So I think that 321 times 5 would be 1,605, right? Yep. So it'd be 18,000, I mean, times e to the power of point. And then, but I definitely cannot do the E in my head, though. So if you don't have a calculator, you can leave your answer like this. Because it says if you don't have a calculator, give the formula you'd use. So this is the formula I'd use to find the answer. Does anybody have a calculator, though? If you want to, you can tell me how much money that would actually be. Pardon me? Oh, yeah, that's okay. And by the way, you can't use a graphing calculator on the final. That's why I bought those extra scientific calculators. So if you have a graphing calculator, then you'll just have to use one of my scientific calculators and give it back at the end of the final. Or you can buy one for yourself if you have one. So that's all for number 12. Now number 13. Okay, find the equation of the line that passes through those points. So to find the equation of the line that passes through those points, I have to find the slope first. So the slope of a line is equal to the rise over the run, which is how high it is at the second point, minus how high it was at the first point. And the run is how far it went forwards at the second point, which is x2, minus how far it was at the first point. So slope is rise over run, which is that formula. And by the way, I'm writing way too big. I won't have enough room for the problem if I keep writing this big. So this is going to equal, let me shrink it down to be smaller. It'll be y2, which is -1 minus y1, which is -7, over x2, which is 4, minus x1, which is -4. So -1 minus -7 is really -1 plus 7. 4 minus -4 is really 4 plus 4. So it's really 6 over 8. 6 over 8 can be reduced dividing by 2 and 2 to get 3 over 4. Like that. So the slope is 3 over 4. And then, so you have to, now you can write this formula down in your note page if you want. That's up to you. So if there's any formula that you see that you don't know if you can remember, then write it down on your page of paper before you take that page of the final. Then the next formula that I like to use for this kind of problem is called y minus y1 equals m times x minus x1, like that. So it's y take away -7 equals m, which is 3/4 times x take away -4, like that. Now this might be a kind of hard problem on the final, but there's only like 25 or 20, there's not, however many there are. It's not, I'm not sure if it's exactly this number, but on this example that I made based on last spring's, there's 26 questions on the final. And then I'm going to add some bonus questions to the final too. The real final doesn't have bonus questions, but I'm going to just secretly add some bonus ones for you as well. So I have seen sometimes finals with as few as like a little bit less than 25, but some finals that have 32, but I think it's going to be about 26 though, because they're usually kind of lazy and they don't really change it very much most of the time. The numbers are always different though, so you shouldn't expect to see any of the exact same numbers on the final. Although one time in the summer, they did actually have the same final the next year. So here we go. Y take away -7 is what? That'd be y plus 7, right? And then x take away -4 is x plus 4. Then distribute to 3/4. So what's 3/4 times x? It's 3/4 x. And what's 3/4 times +4? It'd be 12/4. And what is 12/4? 3, right? So you have y plus 7 equals 3/4 x plus 3. Now I'm going to subtract 7 to get the final answer. So -7 minus 7. And then you get y by itself, because the +7 minus 7 cancels out, equals, and then what is +3 take away 7? -4. And then the 3/4 x stays the same. So do you see how this problem is a little bit harder than intermediate algebra? So you've probably done something similar to this before, but in college algebra, its level of difficulty is a little bit more because you have fractions and things like that. So make sure you're confident in being able to work with those fractions like that. And now we're going to go do number 14. Find the x and y intercepts. So to find the x-intercept, you have to plug in 0 for what? For y, right. So if I plug 0 in for y, then I'd have 3 times x plus 4 times 0 equals 12, right? What is 4 times 0? Is that 40? It's 0. So you have 3x plus 0 equals 12. And you don't have to write the plus 0 because it's nothing. So 3x equals 12. And then what is the x-intercept therefore? Divide by 3 and you get 4. So the x-intercept is 4. So we got the x-intercept. Now let's find the y-intercept. How do you find the y-intercept? Yep, exactly. Perfect. So if I plug a 0 for the x, then the equation would be 3 times 0 plus 4 times y equals 12. Let me move that over. And what's 3 times 0? Is that 30? 0. So I don't need to write 0 down because it's nothing. So it's just 4y equals 12 is the only thing left. Divide by 4. Y equals 3, right? So the x-intercept is 4, the y-intercept is 3. Now I'm going to graph the line based on that. So you'll have to draw your own graphs on the final because it's sort of old-fashioned in a way. but you don't need to make them real fancy. It shouldn't really say graph it. It really should just say sketch it, because you're really just doing a rough sketch. And the only thing you have to show on the sketch is just the, you should probably label the x-axis and the y-axis. Although that's kind of redundant because everybody knows y goes up, but just in case 1,000 years later somebody sees your final and doesn't know the y goes up, it would still be helpful to label it. And then plot the x-axis on the x-intercept. I mean, sorry, I said that backwards. Plot the x-intercept on the x-axis. So what is the x-intercept? 4. So just plot 4 on the x-axis. What's the y-intercept? 3. So plot 3 on the y-axis, and then draw the line. So draw the line. Try to make it straight. I'm super bad at making things straight. There we go. Perfect. Fantastic. Now, we're done with that one. Now here comes a problem that's really confusing for a lot of people, because a lot of people try to find the equation of a line first, and you don't actually have to do that at all on this question. So if you know the idea of what slope means, you don't even need to find the equation of this line in order to graph it. So how do I do that? Well, first of all, just draw the graph, x-axis, y-axis. Then you're going to just label the point -5, 2. Where is the point at -5, 2? Where is that? So it goes left to -5, and it goes up to 2. You said second quadrant, right? Smart. I don't even think I've told you what quadrants are even. So the quadrant up at the top right is called the first quadrant. The quadrant on the left side of the top is called the second quadrant. So that's in the second quadrant. And then how do you find where the next point is if you don't know the equation, but you do know the slope? I'll explain. So remember, slope is rise over run, and the sign of a fraction typically means the quantity of the fraction is negative. And so I'm going to just go apply that negative to the top. So it cannot be applied to both the top and the bottom. So I'm just going to put it on the top. So think of that slope as being -3 on top and 5 in the bottom. So if it's -3 on top, 5 in the bottom, that means the rise equals -3 and the run equals 5. That means sorry, I didn't know that went off the page. My fault. So that means vertically you should go -3, and horizontally you should go 5. So from this point, I need to go down 3 down. Let me use a pencil to do that. So 1, 2, 3, 3 down, and then 5 over to the right. So 1, 2, 3, 4, 5. See that? And then that's where my final point goes. So I'll do that one in blue because I'm thinking about you. There we go. So there's the first point, there's the last point. Now these other points are just empty circles, so they're not really part of the graph. I just did that so that you could see my thought process, because you can't see my thoughts. So as I'm going down and going over, I just wrote those circles so you can see where my brain was looking. So is it okay if I erase those open circles now? So I'll erase those. Perfect. Good job. Now I'm going to draw the line. So make this first point a little bit bigger, then draw the line. There we go. Perfect. Find the vertex axis of symmetry and y-intercept of this equation. So first of all, let's review. This is what we learned about a long time ago when we learned about quadratic functions. The number at the front tells you whether it's opening upwards or downwards. So is this quadratic function opening upwards or downwards? Yep, it opens upwards. And this number inside tells you how far it is shifted horizontally. And it's confusing because a positive actually means it's shifted left. So this is shifted left to -3. But left means negative already, so I'm just going to say left 3. And then this means it's shifted vertically downwards 4. So down 4. And of course, you start from the very center. So if you start from the center of the whole graph, Oh wait, it didn't say to graph it actually. I'm not sure why I'm graphing it, but I'm going to graph it just to show you how it looks, but you don't actually have to graph the problem though, because it did not say to graph it. So if I go from the center, I go left 3, 1, 2, 3, then down 4. I forgot to say 4, down 4. 1, 2, 3, 4. So if I go left 3, 1, 2, 3, and then down 4, 1, 2, 3, 4, what point would I be? Where would I be? I'd be at that point right there, which is -3 and -4, right? So that is the vertex. So that equals the vertex. Now I'm going to make something that opens up starting from there. So ready? If I make something opening up starting from there, it's going to be looking kind of like this. If I make a parabola that opens upwards starting from there, it would look something like that. And I didn't need to graph that, but I did that so that you can see what the axis of symmetry is, though. So what does it mean when it says axis of symmetry? What's that talking about? Every quadratic function, it looks like a mirror image if you draw a line through the middle of it, right? So that dotted line is called the axis of symmetry, because that's like the mirror. And what is the equation of that mirror? It's vertical, so it's x, because vertical lines always have x. And the x value is at -3, right? So that vertical line is, that dotted vertical line is x equals -3. It's where that dotted axis of symmetry is. So the axis of symmetry is, hold on, that's not a good way of doing it. There we go. So that is the axis of symmetry. By the way, do you remember World War II? History of World War II, and they had the Axis powers and the Allied powers. So remember, the axis always makes me think of the axis of evil for some reason. Is anybody in a history class, by the way? Nobody's in history class. So the axis of symmetry, x equals -3. And then what's the y-intercept? So to find the y-intercept, how do we always find y-intercepts? By doing what? Plugging in 0 for x. So to find the y-intercept, we have to plug 0 in for x. So if I took this equation and I plugged in 0 for x, I would have 2 times 0 plus 3. Whoops, you can't see that, sorry. If I plug 0 for x, I'd have 2 times 0 plus 3 squared, take away 4. So what is 0 plus 3? 3. And what is 3 squared? 9. So you'd have 2 times 9 minus 4. What is 2 times 9? 18. And what does 18 take away 4? 14. Yep, exactly. So the y-intercept is 14. So go right here and say 14. Now, if you're doing homework, the homework would probably not want you to just say 14. It would probably want you to say the ordered pair. So what is the ordered pair if you label 14 on the y-intercept? What's the ordered pair of 14 on the y-axis? It'd be 0, 14. So if I get to grade the final, I'm going to give you credit if you just say 14. But once in a rare while, they have like people team grade the final. So if that happens, somebody else might not give you full credit for just saying 14. So just to be safe, you'd probably want to say 0, 14 for that. All right, well, now we're done with page 3. Are you ready for page 4? Perfect. So page 4, it says y to the 4th minus 5y squared plus 4 equals 0. So this is an amazing problem because it's number 17. By the way, did you realize that it feels like it takes more time to get to age 17 than it probably feels like to live all the rest of your life? Have you ever thought about that? Because as you're a kid, time goes slower. So like from age 2 to age 5 feels the same as age 20 to age 50, probably. So if you ask old people, they're like, wow, my whole life went by in like a minute. So if you think about it, you've already lived most of the feeling time of your lives. Have you ever thought about that? So you're getting ready to the point where the time will go by super fast. So 17 y to the fourth minus 5y squared plus 14 is what? Well, you can break apart y to the fourth by breaking it down into y squared times y squared. How does that sound? Does everyone agree with that? And then bring down that minus sign. That minus sign just comes over like that. And then multiply this minus sign times this plus sign. What's a negative times a positive? So that's also a negative sign on the other half. Now multiply the invisible number 1 at the front times the 4 at the end. So what is a 1 times a 4? 1 times 4 equals 4. And now break apart that 4 into every possible way. It could be 1 times 4 or 2 times 2. Those are the only possible ways of doing it. Is there any one of those pairs 1 and 4 or 2 and 2 that if you put them into those blank spots, so the blank spots are right here and right here. Is there any way of putting 2 and 2 or 1 and 4 into those blank spots so that it would add up to negative 5? Yeah, if I did 1 and 4. 1 and 4. So let me double check. So negative 1 and negative 4 adds up to negative 5. And negative 1 times negative 4 multiplies to make positive 4. So you can always check back to make sure it multiplies out to make the original equation, which it does. Now, I actually can go even further than that, because this is a college algebra problem that has more than one level of factoring. So can I factor apart y squared into y times y? Yes, so this pair of parentheses right here can actually break into 2 more pairs of parentheses. So the y squared can break apart into y times y, and negative 1 can break apart into what? Negative 1 times positive 1. Now, I remember one time hearing some students discussing in the hallway whether they could factor y squared minus 1 any further, and they decided they couldn't. So I wanted to say something about it, but I didn't feel like it would be, I thought it would be too awkward. But so hopefully they got it right on their final, but I'm not sure if they did. Now try to help me factor out y squared minus 4. Can that factor anymore? Right. It can factor into y plus 2 and y minus 2. Because positive 2 times negative 2 equals negative 4. Positive 2 plus negative 2 equals 0. Then you have 0 in the middle of that problem. Because y squared minus 4 really means y squared plus 0y minus 4. Now it's all factored. And then let's use that shortcut that I taught you. One time, I briefly mentioned that in algebra, if you take each factor and set it equal to 0, like if I just took this one factor and I said y minus 1 equals 0, you'd have to have y minus 1 equals 0, you add 1 to both sides, you get y equals positive 1, right? So every single factor always has a solution to it that is the opposite of the number that was originally in the factor, right? That's called the fundamental theorem of algebra, if you believe it or not. And it actually took somebody a long time to prove that, but y equals 1, y equals negative 1, y equals negative 2, and y equals positive 2. Although they had to also prove that it always worked, which is a little bit harder to do. So y equals 1, negative 1, negative 2, and positive 2. There we go. Those are the solutions. Now, problem number 18. So I like to imagine that you're growing up through college algebra as you're getting ready for the final. So now you become an adult at age 18 in the final exam. So can you do this problem and be a grown-up college algebra expert? What do you think? I think so. So here's the biggest mistake that I see all the time on the final. People get nervous and they try to do something that's harder than what it actually says. So most people start multiplying this together. However, though, does this actually say to multiply it or not? It just says to subtract it. So don't multiply it. All you need to do is distribute this negative. So negative times 5 is negative 5. Negative times negative 6i is positive 6i. And see you later and have a good game. Good luck. Negative 5 and positive 6i. And then guess what's in front of the other pair of parentheses? There's nothing there, so it's like a 1. See you later. See you. So what's 1 times 12? 12. And what is 1 times 3? 1 times 3i. It's just positive 3i. Now combine the like terms together. So I have 12 and negative 5. Those are like terms. So what's 12 take away 5? 7. And what's 3i plus 6i? 9i. Correct. So if you're lucky like a cat, you can have 9 lives. That's what that stands for. Just kidding. So now we're 19 years old. We're getting older and older and older. Perform the indicated operation using complex numbers and simplify. This problem is really going to be difficult, so I'm glad that we're doing this review right now. So how many of you think you can remember how to do it? It's okay if you can't. Did you know that when I was a tutor in college algebra the first semester, I couldn't remember how to do this problem and I had to like look it up in a book on the shelf secretly? So here's the way you do it. Look at the bottom of the fraction. The thing is you cannot cut a pizza into an imaginary number of slices, right? So the denominator of the problem is an imaginary fraction. So you can't really do that, of course. But if you make the bottom of the fraction be a real number, then you can do it. So how do you make an imaginary number be a real number? You can rationalize it. And to rationalize an imaginary number, oh wait, I forgot. Make sure you don't have your laptops open, just because we have to focus on the final. I just forgot to mention that. But anyway, so 2 minus 5i has to be multiplied to equal 2 plus 5i. But whatever you multiply the bottom of it by, you also have to multiply the top of it by, right? So multiply the bottom of it by the 2 plus 5i, multiply the top of it by 2 plus 5i. And remember what that's called when you switch the sign of something in the middle only, that's called the conjugate of it. So you multiply by the conjugate of an imaginary number to make it a real number. And then you figure out what that equals. Anytime you're multiplying a group of 2 things or more, you need to put them in parentheses. So put those in parentheses and then start multiplying. So what is 4 times 2? It is 8. What is 4 times 5i? It is 20i. And what is negative 3i times 2? Correct. And what is negative 3i times 5i? Yes. Well, almost. Negative 15. What is I times I? Right. So does everybody understand how to get the top of it done? The bottom of it is actually the same way. So 2 times 2 is what? And 2 times 5i is what? And what is negative 5i times 2? Correct. And I forgot the I, by the way, at first, but now I put it back in. And then what is negative 5i times positive 5i? Correct. Negative 25i squared. Now notice something about the bottom. This is why the bottom becomes a real number, because plus 10i and minus 10i eliminate each other in an amazing way, like that. So the first person who figured out how to do all the arithmetic, like division and stuff with imaginary numbers, was so excited he figured it out that he engraved it on the side of a bridge in France. Did you know that? Because he was afraid he was going to wake up and forget how he figured out how to do it. So that's how excited he was that he finally figured out how to divide by an imaginary amount. So I squared represents what? Does anybody remember? I squared represents negative 1. So what is, mentally speaking, what is negative 1 times negative 25? Positive 25, right? So we're going to change that to be 4 plus 25. And then combine together the same thing on the top. What is a negative 1 times a negative 15? It is a positive 15, right? So there we go. And then combine together the rest of the top. What is 20i take away 6i? 14i, right? So 14i. And then 8 goes in front of that. 8 plus 14i. Now combine together a little bit more. So what is 8 plus 15? Is it 100? 23. Correct. 23 plus 14i over what? 29. Right. So that's amazing. So in order to cut a piece of pizza into an imaginary number of slices, it turns out you would have to cut it into 29 slices. Isn't that crazy? At least in this case. In other cases, you'd have to do a different amount. Now, we're ready to do number 20. So are you feeling pretty old now that you're 20 years old in math? So our math age is now 20. So let's plug in 4 minus y into the function. So this is called the composition of functions, when you're plugging another formula into another function. So f of 4 minus y would be, so my mom used to say when you do a function, it's kind of like a little turtle. So everywhere that you have an x, you are going to make a little turtle shell like this, 3, and then a little turtle shell, and then minus 8, and then 2, and then a little turtle shell, and then minus 8. And what's going to live inside of that turtle shell? Yep, the value that you're plugging inside the function will go inside of that turtle shell. So now there's 2 little turtles live inside of it. They're both 4 minus y. Do you like that explanation? Then, now let's simplify that. So we have to distribute those parentheses. So 3 times 4 is what? 12. And 3 times negative y is what? Correct. And then minus 8. And then 2 times 4 is what? 2 times negative y is what? And then minus 8. And then what is 12 take away 8? It is what? 4, correct. 4 take away 3y. Yep. And then what does 8 take away 8? 0, so that just goes away. And you're left with that. So the answer is 4 take away 3y over negative 2y. Boy, it's a lot. What time is it? Remember how last time I ran over time a little bit? Okay, good. We have 13 more minutes. Yay. So number 21. This also is a composition of functions, except this works differently. Does anybody remember how it works if you have f circle g? How does that work? F of g of 2. So basically just say of when you see that circle. So this is kind of like a dot to dot. Does anybody remember doing dot to dots in school? So the first dot begins at the number. Connect that dot to g. And then underneath g, write down what it is if you plug 2 into g. So go down here to g and plug g of 2. So find out what g is if you plug 2 into g. It'd be 4 times 2 minus 5, which equals what? 8 take away 5, which equals what? 3. So g equals 3. After plugging 2 into it, so that's like the first dot to dot. But then that circle also can be thought of as like recycling, because you're not going back to your original number, you're recycling your previous result. So take 3 and plug that into f now. So basically g of 2 equals 3, and then you plug that 3 into f. So what is f of 3? So what would f of 3 be?
5 times 3 minus.
It'd be 5 times 3 minus 2 over 3 take away 2. What is 5? Now, by the way, here's a common mistake. Lots of people do this. They get nervous and they make this mistake. They try to cancel out that negative 2 and that negative 2. But you can't cancel those negative 2's out because negative 2's are subtractions, right? The only thing that you can cancel out from the top and bottom of a fraction is factors. So factors are things that are multiplied and they're factored out from the whole top or the whole bottom. So you can't just cancel out something that's subtracted from the top and the bottom. So you cannot cancel out the negative 2's right now. So what is 5 times 3? 15. And what is 3 take away 2?
1.
What is 15 minus 2?
13.
And what is 13 divided by 1? Correct. So f works out to be 13. And then when you're done with all the dot to dots, that's the final answer. So you're just going to say f circle g of 2 equals 13, like that. So that's all that there is to the problem. So now we're done with problem 4. Amazing. I mean, page 4, I mean. So on Friday, we'll do page 5 and 6. And then, Lord willing, you'll be ready for the final. So make sure you study all the homework really hard, because all the homework and all the tests and everything like that, they're all open right now. So you can go back and improve your grade on anything that you want. And so I'll see you on Friday, hopefully. Hopefully everybody will be here on Friday. So if you know any of those people, hold on, let me pause the recording real quick. So nobody's